Thanks call channel everyone. In this video we are going to study physics, and we are going to consider a fundamental topic in physics, which is motion. Right, motion is fundamental. Now the pattern of our tutoring, or the pattern of educating people, is to first explain the concept about the topic, then solve various examples for your further understanding. So this video is going to come in three parts. The first part, we are going to explain the fundamental concept of the topic, and then in the second part we are going to solve various examples. The first examples, or the first part of the examples, is going to cater for the needs of those that are in the ordinary level, that is people in secondary school, and those that are writing entrance exams like JAMB, UTME, WAEC and NECO, and post-UTME. Then in the third video, we are going to solve various examples for advanced levels. That is the undergraduate set of people, those that are writing advanced exams like the IGMB, the JUBEB, and then the Cambridge 11. So this is the first part of the video. Please join in with us as we explain the fundamental concept of motion. Then the next video will solve examples for the O-level, and the third video will solve examples for the 11. Now, motion is very fundamental. It's a fundamental topic in physics. You need to understand it so that you can understand other topics in physics. Now, motion is studied in Newtonian physics, and then in mechanics or Newtonian mechanics, you have two fundamental aspects. We have the aspect of dynamics, and then you have the aspect of kinematics. All right. So now kinematics should come first. Kinematics studies motion without the force, okay, that causes motion. People define force as an agent of change, because when force is applied to object, they move. So in kinematics, you study about motion without looking at the forces that causes that motion. While in dynamics, you consider forces that causes motion. So you study forces in dynamics. So that's where you talk about Newton's first law of motion, Newton's second law, Newton's third law, and then you talk about other forces, the frictional forces, and the like. So in incoming session and in incoming videos, we'll talk about that later. So now let's begin with kinematics, and then let's look at motion. So when you say motion, motion has to do with movement, okay, of an object. So it has to do with movement, or as some people do say, people say that motion is movement action. So motion is movement action. So when you join the two, you have mo and action. People say that it is, or I do see that it is motion. So movement has to do with movement action. Now for physics, some parameters are used to describe motion, and then that will be the focus of our study. So the parameters that describe motion includes the speed, or velocity, all right, which you rightly know that this is how fast an object is going, right? The rate of the distance covered by an object, or the rate of the displacement of an object. So when you say rate in physics, all right, rate has to do with per time. Rate of change of velocity means velocity per time. Rate of change of momentum means momentum per time. So get used to that. So speed of an object is how fast it is going, the rate of distance covered by an object. So that is speed. Now, the other ones you talk about is acceleration. So acceleration is rate of change of velocity. All right, rate of change of velocity. Take note of the word change. Rate of change of velocity. So what it is going to mean is that acceleration is change in velocity per time. All right, you should be familiar with that. Now we need to talk about something called average speed, because this fundamental, and then they are good concepts to know. So now average speed is defined as total distance covered over total time taken. Note that way because um, you need it to time taking, you need it to pick up some important concepts, some important equation later. So that is the formula for average speed. Now, those three things that I've mentioned are what gave birth to what you call equation of motion, right? The important thing to study under motion are the equation of motion. I'm going to explain equation of motion to you. I'm going to show you how they are formed, because if you are doing advanced level exams, you may need to give back to these equations, and then if you know how they are built or how they have come about, you understand them better. Now, the first equation of motion, okay, um, is from the definition of acceleration that we just mentioned. So I told you that acceleration is known as rate of change of velocity. All right. So acceleration is change in velocity over time. Now, in most British textbook or in Nigeria, when you say velocity, we usually talk about velocity in two ways. We talk about the initial velocity and then the final velocity. So the initial velocity is u, while the final velocity um, is v. For those studying undergraduate courses, maybe you are in part 1 and then you are reading textbooks like Holiday, which is an American textbook. You are going to see your initial velocity as vi and your final velocity as v final. It practically means the same thing. You just need to switch. So that means you can say that since acceleration is change in velocity over time, so acceleration is going to equal v minus u, because you say change in velocity is final velocity minus initial velocity over time. So if I write this equation, I'm going to have v minus u equal at. That is, I did over 1, then I cross multiply. So I'm going to have v equals to u, v minus equals to at. Then if I rearrange, that is, I add plus u to both sides, I will have v equals to u plus at. All right, so this equation is what most people refer to as the first equation of motion. All right, I will not say it's the first or it's the second or it's the third. I will just say that it is an equation of motion. So let's keep this somewhere. I'm going to call it equation 1 because it's very useful, and then we're going to use it later. So that is the very first equation of motion that we'll talk about, v equals to u plus at. Now, let's talk about another one, average speed. All right. Earlier we said that average speed is total distance covered, total distance over total time. All right. So now let's take average speed as it were. That is, when you say something is average, average or mean in statistics means you add everything that you have and then divide it by the total number of items that you have. So now we have two velocities: the final velocity and the initial velocity. So your final velocity and initial velocity, if you are taking average of that, it's going to be v plus u, right, over 2, because that is the average. So total distance over total time taken, so equal to total distance. Distance in physics for most British textbook is written as s to show you space covered. Then the total time is over t. So if I rearrange this equation, that is, I multiply both sides by t, I'm going to have, no, it's supposed to be 1, multiply both sides by t. So this is going to cancel this. Then s is going to be equal to v plus u over 2 into t. Alright, so this is another equation of motion. So S is equals to v plus u over 2 into t. So this is another equation of motion. You can call it second equation of motion if you like, but this is another equation of motion, so I call this equation 2. So understand where this is coming from. Average speed is taken as total distance over total time taken. When you say average speed, ideally, average is addition of all the items and divided by the total number of items that you have. So the items that you have are your final and initial. So add the two, alright, divided by 2 to show average. So equals S over T. Alright, then rearrange the equation, multiply both sides by T, this cancel out, and then you give back to this equation. So that's the second one. Alright, so now let's see how the next equation of motion is given back to. So from the first two equations that we have, let me write them again. V equals to u plus at. Second one is S equals to v plus u over 2 into t. Alright, you can form your other various or the remaining two equations that are used in describing motion. So now look at this equation, v equals to u plus at. Now, from this equation 1, if I make t subject of formula, I'm going to have t equal v minus u over a. Alright, make t subject of formula. So you take u to the other side and divide all through by a. Now, if you substitute that in equation 2, it's going to give us something very interesting. So equation 2 says S equals to v plus u over 2 multiplied by t. So in place of t, we're going to substitute this. Okay, we're going to substitute this in t. So that means we're going to have multiplied by v minus u over a. So what we'll do is we'll multiply both numerator and denominator. So this is going to have v plus u multiplied by v minus u then over 2a. Now, if you're a very good student of mathematics, what you're going to notice is that we have what is called difference of perfect square. Remember that you have a squared minus b squared equals to a plus b, a minus b. That's what you call difference of perfect square. So that means in our numerator, we can do difference of perfect square. V plus u into v minus u is going to give us v squared minus u squared. That is what you call difference of perfect squared. So if I do this over 1 and I cross multiply, I'm going to have v squared minus u squared equal 2as, right? Then if I take u squared to the other side, I will have v squared equals to u squared plus 2as. I'm sure you are familiar with this. This is another equation of motion. So let's call it the third equation of motion for the sake of our own learning. So this is where this equation is from, right? The reason why I'm taking time to explain how this come about is for your understanding, and you can also know where they are obtained from. They are not just random equation that was obtained. Is from carefully looking at the definitions of acceleration and definition of average speed. Now there's one more we can do. So let's see one of the other equations. So coming again from our initial equation, v equals to u plus at, and then saying S equals to v plus u over 2 into t. So what we can do is in the second equation, in equation 2, this is equation 1, this is equation 2. So in the second equation, since the first equation is v equals to u plus at, so in the second equation, what we'll do is we'll substitute u plus at for v. So we'll write equation 2 as u plus at plus u into t over 2. So what we did was to substitute v in equation 2. So for this v, instead of writing v plus u, we plug in u plus at equation 2. So now let's rearrange. U plus u are the same, so we have u plus u, that's going to give you 2u plus at over 2 into t. All right, so let's open up the bracket. So this is going to give us 2u times t is going to give us 2ut. Then at times t is going to give us at squared over 2. So s is going to give us this. Now, this is a fraction which we can separate. So we can say 2ut over 2 plus at squared over 2. 2ut over 2 is going to give us ut. At squared over 2 is commonly written as a over 2t squared. So I'm sure you must have seen this before. So this is the fourth equation of motion, and then or the other equation of motion that you have. So if you are writing exams, or if you are in secondary school, if you are writing exams like WAEC, NECO, UTME, post UTME, you will not need to know these derivations. What you just need to do is understand them and know how they come about. But if you are writing exams like IGMB, you may need to know how to derive this kind of equation, because most IGMB equations or questions involve derivation. And then if you are in part 1, um, and you are in schools that write theory exams, you may need to know how to do this derivation. So let's put everything together. So the first one we talked about was v equals to u plus at. Now the other one is s equals to v plus u over 2 into t. Then the other one is v squared equals to u squared plus 2as. And then the last one was s equals to ut plus half at squared. And you know what all these parameters are? V is final velocity, as we have said. S is the distance covered, or space. All right, distance covered. T, of course, is time, and A is acceleration. So it is good that you know them in their unit. So the SI unit of acceleration is meters per second squared. Time is measured in seconds. Distance is measured in meters. Final velocity is meters per seconds. And then, of course, your U is initial velocity, which is also measured in meters per seconds. Now, the good thing is that what we have done is we have just described one aspect of motion, or one type of motion. I will quickly explain type of motion as the last part of this video. So now the type of motion, I will circle back to this. So the type of motion that you have, all right, now type of motion. So not rigidly, or let me say loosely, the type of motion that you have can be categorized as linear or translational motion. Then you can have what is called circular. Take note, I said loosely. Circular or rotational. Then you can have periodic or simple harmonic motion. Then you also have the random motion. Some people say to me that, oh, what of relative motion, what of instantaneous motion? All of those can be categorized into any of these. And then even with these, some of them are interwoven. All right, so now linear motion is a motion that occurs on a straight line. That is, it is one dimensional. That is either the object is going up vertically or going horizontally. It is one dimensional. So example of a linear motion is an object thrown vertically upward, or if you push a box along the horizontal floor, that is linear motion. So of course, circular motion is a motion along a circular path. Now periodic motion is a motion that repeats itself at constant interval. Now understand that there is a difference between a periodic motion and a simple harmonic motion. A simple harmonic motion is a periodic motion, all right, but not all periodic motion simple harmonic motion. When you say a motion is periodic, it repeats itself at a constant interval. But a simple harmonic motion is a periodic motion, right, which is linear or almost linear. All right, it occurs along a straight path. There are going to be other videos that will explain simple harmonic motion and explain all of this in full details. But for the sake of categorization, let's talk about this. So random motion, of course, motion that is Brownian or motion of particle haphazardly is random motion. So what we've done so far is to talk about the equation of linear motion. So the equation of linear motion is what we've talked about here, and then you have them already. So now the reason why I mention linear motion is because I say linear motion is a motion that occurs along a straight path. It can be vertical, it can be horizontal. So all of these are used to describe equation of linear motion when they are horizontal. But if the motion is somewhat vertical, all right, in a vertical motion, the acceleration of a vertical motion is supplied by gravity. So instead of writing A, we write G. So instead of saying V equals to U plus AT, say V equals to U plus GT. Because when an object is moving vertically, right, it is moving under the influence of gravity. That is, what supplies the acceleration of an object moving vertically is gravity. So you write G. So instead of V squared equals to U squared plus 2as, we say V equals to U squared plus 2gs. Then instead of saying s equals to ut plus half at squared, we say ut plus half gt squared. Then also this one also apply, v plus u over 2 into t. This applies. So all these equations are for vertical linear motion. Okay, vertical linear motion. That is when the object is moving under gravity. That is, it is thrown vertically upward or it is falling from a height. This is for then this other one, okay, this other one is for horizontal motion. That is when the acceleration varies, an object moving horizontally. So all these are things that you need to absorb. So in the next video, we're going to solve equations, because you must be able to know how to apply these equations, all right? Because there are instances when the final velocity will be 0, when the initial velocity will be 0, and then instances when you have to use plus, you have to use minus, depending on the scenario of the question. So in the next videos, or in the next video, we are going to solve some questions for the O-level set category, and then in the other video we're going to solve some more advanced questions from Cambridge A-level, questions from IGMB, JUPEB, and part 1 questions, so that every other person we will get that for. So thank you again for watching this video. Please like the video, subscribe, and can share the video, and then put on the notification button, because we are going to give you a lot of more important and interesting content. Thank you. I'll see you in the next video.